All right, good morning, everyone, and welcome to this month's Boomerang Labs webinar exploring how to reframe product design around difficult to recycle materials. We're joined by Think Fencing's Jack Fitzgerald, Circular Design Co.'s Liam Gibson, and Reynard Wood's George Reinke, who will offer insights about how today's companies are designing their products to keep waste out of landfill. But first, as Labs' communications manager, I literally wouldn't be doing my job if I didn't tell you a bit about us and this series. So, we're Australia's first startup accelerator specifically for circular economy founders. And while most of our programs are more intensive, we wanted to have these free webinars to provide learning opportunities on different topics of interest. So, next month, we'll be discussing mastering brand and digital strategies to grow a circular economy business. And that's going to be on 22 May with Dan-Ling Zhao, creative director at Rico Digital and a Boomerang Labs alum. And you can check out our events page on our website, follow us on LinkedIn and Instagram, and subscribe to our monthly e-newsletter to get all of the latest from us. We do also have those more in-depth programs for startups at different stages, so please do check out our website if you're interested or if you know someone who might be. And I'm joining this morning from Gunditj Mara country, and I'd like to acknowledge the traditional custodians of the lands on which we all live and work, and pay our respects to elders past and present. And now I'm going to turn it over to the folks that you actually came to hear from, starting with Jack.
Fantastic. Thank you very much, Alison. Can you hear me okay? Yeah, outstanding. Well, firstly, I'll just give you a bit of a preamble as to why I might not be functioning as well as I probably should be today. We've just had our second child, a newborn, arrive at home last night. Last night was sort of not very much sleep. So I'm on my second or third black coffee, and hopefully that'll be able to kick things on a little bit, and I'll make a little bit more sense than I was at 3 in the morning. Cool. Well, thank you very much. So Jack Fitzgerald's my name, and thank you, Alison, for the opportunity to present around circular economy and product development. Now, I'm from a company called Think Fencing. I'm the founder and CTO of Think Fencing. So you might be thinking, what does a fencing company have to do with the circular economy or recycling? And if you're thinking that, it's a very good question. So my company started around about 25 years ago when my mother's horse ran through a fence and cut itself up beyond repair and had to get put down. So that was when I was around about 16 years old. And the reason that the horse ran through the fence was purely because it couldn't see the fence. Horses are flight animals, so when they get spooked, they just run. So I came up with this product that clips over the existing plain wire fence purely to enhance the visibility. If I grab that, enhance the visibility of the fence. And it was a little product called Wire Coat. So that's a 2 millimeter fence wire, and this was a strip of recycled plasticized PVC that clips over the wire to make it more visible. Really simple, basic product made out of flexible PVC that I started extruding on an old extruder in our shed that was surplus to my father's supplies. So he was in the plastics industry a long time ago, making PVC downpipe and fitting. So not that exciting, but it was plastic. So that was where my introduction into plastics came and where the start of the business was from. So from that one product, we expanded our range into a full range of PVC fencing products, picket fencing, privacy screen fencing, and recently racetrack running rails. So most thoroughbred racetracks you see in the Southern Hemisphere have been made by us. So the white rail where the horses run around, and it's extremely safe. So for horses and jockey. And also we manufacture a product called EcoDuct, which is a low-rise ventilation product made out of recycled PVC and adheres to all of the building codes and fire, more specifically the fire ratings required. And composite decking we're going into, plus a whole range of other products. But anyway, what I'm here to talk about is what we've actually done more recently around circularity and developing products out of recycled material and the whole thought process that we've put into this. So around about 4 years ago, we had a lot of PVC waste, which we were producing, and also fabricators and contractors were producing from cutting fences up, fabricating a fence from a long profile, routing slots in the profile to accept the pickets or rails. And we didn't really have a good outlet for that. So with PVC, it's notoriously one of the most difficult polymers to recycle because every time it goes through a process, be it extrusion, injection molding, blow molding, or compounding, it loses some of its heat stability. So we need to understand how much heat stabilizer is left in a polymer, modify the polymer with additional heat stabilizer and bring it up to a certain standard, which can then be processed into whatever product it's been made, whatever product it needs to be made into. So on the back of this technology, developed in collaboration with the CSIRO and partially funded by Sustainability Victoria, we we started to come up with some really, really good ideas, and it just opened the floodgates of what we can do with other products, other recyclates available to us. So over the course of the last 4 years, when we developed this technology, we started developing products and collaborating with other companies, such as the Australian Resilient Flooring Association, JR Recycling, which is copper cable, PVC sheathing, and also Crown Casino, their playing cards, Pharmacycle for recycled blister pack medical packaging, and Aluplas, PVC window recycle manufacturer. So from all of these collaborations, we developed a system that just works for recycling PVC and recycling other products, and it turned into a all-encompassing product development, recycling, circular thought process. So where we start is we actually start with the problem. So the problem in most of these applications is the product. So if I show you this here, this is recycled PVC cable insulation. And if we also look at this here, this is recycled vinyl flooring, PVC flooring, plasticized. I know just through one supplier, there's around 20 ton of this available that doesn't really have a home. So unfortunately, a lot of it goes into landfill, 20 ton a month. This product here is the PVC flooring. Around about 8,000 ton of this goes into landfill per year, 8,000 ton. And it's beautiful material, but no one's come up with a solution. So what we do, we start with the problem. So we've seen what the problem is. And in the end, we don't want to get to a product. We don't want to get to a solution or anything like that. What we're striving to get to at the end is what we call appreciation. Okay, so appreciation. When you're sitting outside on your deck, for example, on behind one of the Reynard wood paneling, sort of retaining wall panels, you're looking at that, and what we ultimately want to get to is appreciating the product and the process that we've gone through. So I'm going to run through our process and our thought process that we use internally, and we want to share with you guys because it works in this day and age. Product development, industrial design, it's changing rapidly. And now more so than ever, the push is around sustainable building products and sustainable products that can be used over and over again, and they work. So after we've got the problem, we then look at the processing and the technology. So that can be in our situation, the technology is the actual the analyzing. So we analyze the material, we look at the actual material, how it performs, what we need to do to modify it, and then from that point, we can then start to go into what we can make with that material. So we've modified the material. We know the properties that we've got out of it. So let's look at a case study using the flexible flooring and the PVC cable sheeting. So it's flexible. We can get it to process really well. We can get it to homogenize. We can understand its heat stability. We can modify its rigidity. And also we can put a capping layer of a color over the outside if we need to, using technology, which is a co-extrusion technology. So it's innovate. So we look at the innovation side of it all. So what products can we make? Okay, we can make it into another flooring material. We could look at making it into boat bumpers over the side of boats or on piers. We can look at anything that requires flexibility and resilience, because both of these original feedstocks are very resilient. So innovate, design. Okay, so we've also gone down to looking at flexible garden edging, for example, which is the product. So innovate, though we're innovating, we design, come up with new products, we test those designs, and then we rinse and repeat. Now, we say rinse and repeat, what are we looking for? So I categorize everything into 5 categories. Possible, so okay, the technology, the idea, the concept, the end product, it's possible, we can do it. Second is possible, but costly. So, okay, whilst the technology is good, we can do it, we can make the product work, but does it cost more than what it would cost if it was virgin, or is it pricing itself out of the market? You need to look at cost, because ultimately everything's driven by cost. So then number 3 is possible and it's economically viable. So, okay, we're sort of heading in the right direction. So there's light. We can see light at the end of the tunnel with this. Number 4 with the design is possible, economically viable, with external buy-in and collaboration. So what I mean by that, if we look at the problem over here, so call it recycled flooring or flooring that's come off the ground, the producers of that flooring material, they want to buy into your process. They like the idea. They want to collaborate. And you also look at collaboration with recyclers, with learning institutions, government funded, partially funded associations like CSIRO. And then you look at buy-in with actual people who will potentially use the product or sell it. So, okay, so it's possible. You've got a bit of it's economical, and you've got some buy-in. That's good, but it's probably not good enough. So number 5 is where we want to keep going through this thought process, which is we call the no-brainer. So you've got collaboration and buy-in from both the problem and the solution. So the problem is the supplier of the material or the creator of the material, the waste. Then the solution at the end is the customer. So if you've got buy-in for someone who wants to join that that recycling journey with you, being the at the beginning where the waste is created or the opportunity is created, then at the end you've got the customer, which is the solution, and you've got everything else in between. So we keep going through that: innovate, design, product, rinse and repeat, innovate, design, product, rinse and repeat, and gauge where it sits on that scale of 1 to 5. And after you hit a solution that's a 5, then we go into the push stage, which is logistics. So there's a lot of logistics. It doesn't matter what product you're looking at around recycling and circularity. There's always going to be logistics. So we've got to work around the logistics. Then we have to scale up. So the initial technology that was created, we have to scale up, bring that into a commercial quantity or production. So we need to bring it up to the next level. Then it's manufacturing. So that scale up of recycling then flows into the machinery, the manufacturing and the process, and then it's market. So we've already established that we've got buy-in from the problem, which is supply, and then the solution, which is customer. So then it's about that market, creating that market. So from push, we then go to flow, which is the customer. So we know who the customer is, the ideal customer at the end, because we've already established that in that product evaluation and thought process. Then it goes to sales. So it sells the product. And then at the end, which is the most important part, because we started at the problem, then at the end is appreciation. So after you sell that product, it can't be just a product that is installed once or it's done once and that's it. It's what we really look at is that whole idea, that whole thought of having an item in your house, on your car, that's been seen daily, where you can go out there and you're proud of it and you appreciate it. So we go from problem to appreciation. And that's basically the process that we use internally to evaluate our systems and our technology. And when you've got buy-in from the the problem, being the producer of the opportunity or waste, so we call it the producer. I try not to use scrap or rubbish or waste. I use the problem, that's the opportunity. And then at the end, if we can achieve appreciation whilst hitting all those points and going through that thought process from possible to a no-brainer, you've got something really, really interesting. And that can be applied to not only recycling material, but systems and processes within any company. So it's a new way of thinking. So um, on the back of that, I'll just show you a couple of products here because I know that Alison likes my little props. So we've got, this is the recycled PVC cable sheathing. Pretty easy to recycle with our technology. There's not really technology like this that exists in the world around this, what we're actually doing, but it's not to say it can't be done with other products. Recycled chopped up vinyl flooring. This is blister pack from medication, chopped up and recycled. And then this is PVC window profile. So all of these products that I just showed you there are all actively being upcycled into new products within our company using this process. So I hope you've all been able to get something out of that in my sort of sleep-deprived state. But it does work and it is exciting, and we're very passionate about pushing any opportunity into that direction, from problem to appreciation, not from product to sales, problem to appreciation. And I'm happy to answer any questions if anyone has any, or lead on to the next next stage.
Yeah, thank you so much, Jack. And if anyone does have questions for any of the guys, we will have a Q&A at the end. But for now, we're going to turn it over to George to give us an idea of how his company, Reynard Wood, is doing this in practice on their end.
Oh, hi there. Share my screen. Here we go. Sorry, everyone. How we going there? Share. There we go. Hi, everyone. Thank you for attending today, and thank you, Boomerangs, for hosting this, and thank you, Alison. My name's George Reinke. I'm the founder and director of Reynard Wood, which started out with some sort of timber products, but quickly spun into a material opportunity. We're a product manufacturer collecting infinite industrial waste materials and creating an outdoor product to begin with. That's pretty much fake wood. So even though Reynard Wood says wood, it's actually got no wood in it. It did start out to have wood foam or wood waste, but we've moved to hemp now. So biogenic carbon. The opportunity really is, to begin with, is to show that this is proven in the outdoor climatic conditions of Australia. And firstly, starting out to replace timber sleepers, which pretty much deteriorate over time, where this product has the potential to last 30 to 50 years, being a cementous-based material. The constitution of the product is a mixture, and it sets quite quickly, and it's much like a lightweight concrete. However, it's not brittle like concrete. It's actually ductile. So it actually has this unique ability to flex and self-strengthen before it fractures. So it does have an element of safety around it as well. When we start implementing ways of reinforcing the material and making structural solutions that can handle extra weight. So there's a picture of the product that itself, the second version now, which is now at 2.4 meter length. and paint injected to have the look and appearance of a timber sleeper. The vision really is to, use the industrial tailings waste, where Australia is actually extracting a third of the world's iron ore as a mining provider, and also a third of the world's bauxite, which is the byproduct into alumina for aluminium. 80% of this raw materials is actually getting sent to China, and China's got very good at, I guess, sorting and getting high quality grade of industrial waste stockpiling. And that's where we actually got an offshore factory and starting out producing from that instance to create this product over time. There is interest to set up and start up an Australian factory, because that's obviously true circular economy. We're actually using our own waste in country and creating products from and obviously Australia's moving to a more manufacturing ambition, which is good to see. The material is actually an international known standard. It's nothing new, called a high performance fiber reinforced cementous composite. The only difference is that instead of just using, material from our raw environment, we're actually using waste. So we're using the industrial waste, which is cementous, which actually comes from producing steel, which is the ground granulated blast furnace slag. And it's the first stage of the materials that, when we're moving the iron out of the dirt, we can start using for products and repurpose into the environment. So therefore, we've got the industrial waste element, we've got the hemp fibers to bind it together, and we've actually got structural bamboo rods to create the ability to have decking, basically, and retaining walls and other sorts of forms of products, where it adds that strength and integrity to the product. What's quite important is that we did think about this years ago to look to inject plastic into it, because when we do put plastic into it, it does help it get longer and thinner, easier. But we chose not to have any plastic at all. So the whole objective is, by not having any plastic in this product, it can be easily recycled. So for anyone that's using it in a national way, with offcuts, any elements or pieces, they can simply take it to the local government recycling centre, and you can drop it off there with the cement concrete area, and it's acceptable. So it's quite an opportunity to scale in quite a vast area across all consumer and commercial, and know that we can keep recycling this product at the end of its life. Version 1 started at 2 meters long, and we moved to 2.4 meters. We've been testing 4.8 meter length now for about 3 years at factory. This does take some time, so we've been going for 4.5 years in market in Australia. And we know that, with a building product or a builder has to guarantee any project, particularly landscapers, for 7 years, and I think that's might even be extending out longer now. So we're getting closer to that 7-year mark, where we've had no complaints, no issues. There is, it's not the most best refined product yet, but we're sharpening the sword. That's so they say. It takes time to get it better and better, and it does take time, and it's good to know that we are going in a good direction. So there is an opportunity for cladding in the future, and fencing as well. Anything that was particularly a wood product outdoors, we're kind of targeting. It's been a very well responsible approach with certification and testing within Australia from the beginning of actually late 2019. The company was spun up mid-2019. First product was landing here in September 2019, and we've done a lot of tests, a lot of investment to make sure. We've actually got a research partner on board now with University of Southern Queensland and Future Materials, and also Western Sydney University want to continue and also help with anything that we might need, which we did start out with them from a structural testing perspective. And we've had great support from government, with Australian IP accepted for health protection, will give us a bit of a direction. We're here to push the market forward and help lead the market forward. Materials Embodied Carbon Leaders Alliance is an area of government where bringing all industry together to get the industry to net zero is quite important. We've been involved with those groups for a couple of years now. We've got Infrastructure Sustainability Council, and then of course Energy Lab and Boomerang Lab to help sort of boost us up to the next step and give us a bit more energy. It's very good, thank you. So far, we're up to 2024 now, and we just sort of held off any more shipments until we sort of resolve the second version, where we're injecting color into the product. And it's quite common in concretes, when you try and put colors in the concretes, you get what they call efflorescence. So we're just working through that at the moment with the university and getting acclimatized in the next step. And then we'll be shipping the next product, which we feel will be very close to scale stage to be able to then distribute through our channels that we're targeting. But as you can see those photos, the top row of photos is version 1, which is the 2 meter length plank with no color. And the bottom row of images is actually the colored version of the 2.4 meter length, which is what all the builders and a lot of the feedback was coming back on what length to do next. And what's really important about this product or interesting is that it actually does work like wood. So you can actually cut it, saw it, nail it, drill it, even with your standard tooling, your wood tooling. Now, if you do use your standard wood tooling, it will wear your tools out quickly. So it's good for the DIY for a couple of one-off projects. I don't need to buy any specialized tools, even though the blades or the bits are not that expensive anymore. You just got to buy a different style, all available in Bunnings, Mitre 10, or your hardware distributors. If you look at the bottom image next to the saw blade, you'll see how there's a retaining wall and a deck and a garden bed about to be built, where you can see there's old timber posts in the ground. That was an old timber retaining wall, which had about a 2 meter span between the posts with 2.4 meter planks. So what we're able to do is all the other timbers had rotted away, is maintain those original thicker timber hardwood posts and not replace the whole system, and actually retrofit with this product, put an intermediary post in and use the product as another post to strengthen it up and extend the life of that system, which also saves the residential homeowners time or money, and able to keep that system life cycle going even a little bit longer. So there's another opportunity with this product and help with existing systems in place at the moment throughout the country. The marketing plan has always been the same. We really want to just distribute through the big distributors, which we've been going through the independent hardware group at a small size, only no more than 20 stores, but then backing down to about 5 until we get the product refined right. And it's a process of, and they've been very well supportive as well, but we really want to make this product accessible, because when we get this right and we scale it out, we can get the price down as well. We can actually get to a point where we already are at the same price as hardwood timber sleepers, but we could get down to softwood timber sleepers. We can actually really make a big impact into the Australian market. Local governments are a big target we want to get to once we're ready. Property developers, we're already talking with some very large ones that they want to support as well. We want to make more new products, bigger, thicker sleepers, potentially the subflooring beams for these deckings that no one has a solution under 30 centimeters off the ground, because the timbers will rot out too quickly from moisture, or they're steel and they're hard to work with. And we're really looking out now next for an Australian factory partner. So really keen to, if anyone, Jack or someone else would like to get involved, we're looking at potential investment and partnerships to get an Australian factory going in short term rather than mid or long term. And yeah, all I can say is it's really a great opportunity to be involved with, and it is a lot of hard work. And from a landscaping point of view, I can really appreciate these people that work in this environment as well, because you're always working close to the ground, and it's quite difficult when you are close to the ground with moisture and what products to use. So this product could actually open up a lot more activity for these workers or these other businesses to start using this product more at a more cost-effective rate for customers that might want to do more in their outdoor landscaping properties, as an example. And other than that, I could just say thank you very much again for your time, and thank you, Alison, and everybody. That's the end of the presentation.
Great. Thank you so much for that. And I think George has made a really good point that we don't always discuss. And there's a saying that perfect is the enemy of good. So I really love that George has brought up the fact that product development is not, it has to be perfect the first go round. It's very much, there will always be refinement. There is always room for improvement. So thank you for that, because I know that the fear that something won't be perfect right off the bat can keep people from pursuing it. And I think that's a really great point. So up next, we have Liam. If you want to take it away.
Sure. Thanks, Alison. I'll just share my screen. Okay, we all see that? All right. My name's Liam Gibson, and my company is Circular Design Co. And thanks, everyone. It's great to meet you and great to talk today about hard to recycle materials. I've been enjoying listening to Jack and George go through and hear the common themes and common experiences that we've all had in working with these type of materials. So just a little bit about me before we get into it. So my background is as an industrial designer, and I've been doing that for about 15 so years. And really, it was probably about 4 years ago that we really started focusing a lot on the circular economy and understanding what's going on there. And I've shown a real interest in that. And about 3 years ago, we created our first platform, which was the Circular Material Library. So hopefully a few of you are aware of the Material Library. And we created the Circular Material Library basically as a platform to help promote more circular design, but also as a way to showcase and promote all the new and exciting materials that are currently being developed around the world at the moment. One thing that we're seeing, and it's great to talk about this topic today, but above and by far the biggest trend that we're seeing is that there's a huge amount of materials around the world that are being created from waste streams. So, these are large companies doing it. These are small startups, these are individuals, but just the amount of innovation that we're seeing at the moment for waste streams is really impressive. So from a design perspective, materials made from waste, it's really important to recognize that it's a hard thing to do. And, it's humbling to also hear the stories that, Jack and George are going through as well with all their R&D and all the testing and the evaluation that they have to go through, because these materials, it's important to recognize that they are quite hard. But from a design perspective, when you start down this journey, one of the things that I find really important is to think about in terms of value. So we're taking material that doesn't have a lot of value, and we need to work out ways to add value back into that material. And the best way that I like to do that and showcase and talk about this type of thing is with the value hill or the value pyramid, which I'm sure some of you would have seen before. It's a great way to compare the linear system and the circular system when it comes to product design. Both systems share the same pre-use steps where you go through extraction, manufacturing, assembly, and then retail. And then that's when it hits the user. But there's the big differences after that. The linear system with post-use, all that value is destroyed. But in a circular system, we want to retain that value. And this is a great diagram, and it's a great tool to showcase and put into perspective all the buzzwords and strategies that you see get thrown around when it comes to retaining value. So you can see you've got repair, reuse, redistribute, refurbish, and manufacture. And then down at the bottom, you've got recycle. So on today's topic, which is hard to recycle materials, I think it's important to recognize that we're right here down the bottom. So we're something that doesn't have a lot of value, and it's important to work out how we can add value back into the system. Starting with design and what role designers can play. Probably the first step, and the really important step, is to understand the unique characteristics of the material that you're working with. So I'm taking quite a broad and top level view of this type of thing. And this is a lot of based on all the discussions and partnerships that we have with all the material suppliers in our library. But it's really important to understand what you can't do with the materials that you've got. What's the unique points of difference that those materials have? And then from there, it really gives you two good options. And, typically you can see two things happening. You can create another material, which is really inspiring to do. You can take a waste stream, you can take a hard to recycle material and make another material with that. And some really good examples of that we're seeing in the textile industry, where huge amounts of new bio-leathers and new textiles are being made from food waste, which is really inspiring. And then the other option that you can really do is create another product. And that's somewhere where you can add a lot more value to what you're doing, but then it also has a limited marketplace as well. It's a good thing to talk about this here in Australia, because what we see with the library is that most of the material innovation is coming from overseas. So there's a huge opportunity for us down here in Australia to really take our waste streams, look at the inspiration that's happening over there, and do something down here. When it comes to strategies, it's really nice. And, I quite enjoyed listening to your talk, Jack, about, I think we've come across very much the same issues. And first up, it's really, do you have a product sponsor? If you can get someone to help support you in what you're doing, whether it's in the collection phase, the manufacturing, whatever it is, whether it's a business or an organization or a government organization, whatever it is, a product sponsor will go a long way. The other aspect that's really important is that we need to make sure our customers care about what we're doing. They might be involved at different stages of the process. They might be collecting the material. They might be working with it. They might be the end user, but you really need that buy-in from them and for them to care about what you're doing. And then last, the important thing as well, and this is really from the design and marketing perspective, is that storytelling is so critical along the whole journey to add value to what you're doing. You know, people want good stories. They want to know they've got something made from a waste stream, or they, you know, repurposed materials from landfill, whether it's got, you know, your diverted landfill, whether you're reducing emissions or you're designing out waste. That storytelling is really critical. It's really important to realize that each new material has its own set of unique properties, features, and characteristics. This is just a bit of an example that we're using at the moment. So this is a mycelium clock that we have here at the moment. So this is basically, I grew that last week. Okay, so this one's fresh out of the kitchen. And what's really interesting is that we're going through what design features we can and can't do based on the waste substrate material that we're using. So whether we use waste, agricultural waste, straws, those type of things, or whether we use a sawdust waste, it has a huge influence on what we can actually do in the design. And a good example on why I've shown this image is that you can't actually see very well the hour indicators on this clock, but that's because we used a straw substrate. You know, if we were to use a sawdust substrate, all that detail would come through. And these are all kind of things that you don't know about at the start until you really get in there and get in the weeds and dig and work out what are the limitations or the properties of what you're working with and what they can do. The other design challenge is that most of these hard to recycle materials often involve other materials in the solution. So you need to sort of realize that if you're adding materials to a product or to make a new material, that what you're adding is not making the situation worse, that you're actually improving and you've got a plan for what you're doing. The other really critical part from a design perspective, and you know, this is the key part of circular design, is that we need to be able to zoom in and out throughout the design phase. So what I'm talking about there is that as we're designing something, as we're working something out, we need to implement design changes, whether it's design features, material selection, manufacturing techniques. And through this design phase, we need to also zoom out frequently to understand the impact of what we're doing. So the good news, though, is that there's new tools and there's a lot of resources that can help us do that. And I just wanted to showcase today a program, a company that I've had a little bit to do with over the last 12 months called Carbon Sync. So what Carbon Sync does, and it's really valuable as a designer, is that as we're going through this process of designing a product, we can take our materials, we can put our manufacturing techniques, we can put our material selections into the program, and it can give us real world data on those carbon emissions. So for us, that's really valuable because it can give us that instant feedback. And this might be something that we do 10, 20, 30 times through the design phase as we go in and out, zoom in and out, understand the impact of all our features. I just wanted to go through and show just a little bit of material inspiration, just so we can help promote. Hopefully we can see some new materials, especially coming from down here in Australia. But here are a couple of my favorites, which is we've got materials made from food waste up the top with Fabula, which is a Japanese material, and they use waste, coffee grounds, tea leaves, and citrus to make bowls, cutlery, plates, that type of thing. Down the bottom there, we've got LOVR, which is a compostable bioleather, which takes hemp residue and turns it into an innovative new material. And then, you know, they're material inspirations if you go down to making a new material side. From a product perspective, you know, Yi Tiles is a great example of where they take construction waste, they take ceramic tile waste and turn it into new ceramic tiles. And then down the bottom there's Effect Footwear, where they take casual shoes and they use old shoe crumb rubber in the soles. And you can see the little flex. And I like this as a good example too, because, you know, if you didn't know what was going on and if you didn't have your storytelling down pat, you wouldn't know what's going on there. But the storytelling allows us to understand and add more value to the product and be a nice point of difference. These are just a little, I thought I'd do a little show and tell about these are things that we're working on right now in the last couple of weeks. Here we've got some bio tiles that we're working with a UK company with seashell waste to create a range of, you know, we're looking at coasters, we're looking at other ceramic materials, and they use a algae-based binder to bind them together so they're non-fire. We've got the mycelium products where we're making light fittings and clocks that we talked about before. And I've just thrown in an old project of mine, which is a surfboard cover, where we looked at a lot of waste sails, and we look at how could we repurpose and reuse all the waste sails that come from the sailing industry. Just to finish up, just a couple of key takeaways if anyone's looking to develop and create their own material. First off, it's just, really think about value. How can you put value back into that material? How can you recapture all that value? Partnerships and collaborations are really important. Embrace the material's point of difference and understand what it can and can't do. Be practical, start conservative with your testing, understand what the material's available, what can it do. I threw this one in as well just to make sure that we include circular design principles, just so we think about the full system and the end of life, and that we don't add another linear material into the mix. And last but not least, and you touched on this just before, Alison, but you don't need to know everything. Explore, experiment. It doesn't need to be perfect. These materials are really hard to work with, and until you really get in there, you don't really know what you're going to see, what you're going to expect. That's just some acknowledgements for some of the info that I've put in there. And yeah, if anyone's got any questions or want to reach out, that's just my email there at the bottom. But thanks. Hopefully that was some value for people.
Great. Thank you so much, Liam, George, and Jack. And so now we're going to open it up to questions. If anyone does want to ask anything, just go ahead and put it in the chat. We did have one from Dylan. It was specifically for Jack, but if the others have any thoughts as well, have you ever used or considered using LCAs to drive product decisions as well?
What's an LCA?
I don't know. Dylan?
I can jump in on that one if you want.
Yeah, please.
So LCA is a life cycle assessment. And that's where we look at the impact of a product over the full life cycle of the material or the product of what you're doing. And just jumping on this one too, because that little carbon sync program that I threw up there before, that is an instant LCA micro feedback for designers through the process. So you get that impact assessment as you develop and design. So
yeah, it's interesting. Sorry, I'm not very good with my TLAs, three-lettered acronyms. And there's a lot of them out there, but I do know what an LCA is now. Sorry, lack of sleep. Look, it's very interesting, and we're starting to really push down this path in a big way, especially for exporting over to Europe, because I think a lot of you probably know about I think it's the digital carbon passport for any product being exported or imported into Europe. We need to sort of have all of that information available for any product being exported. So whilst we haven't been conducting specific life cycle assessments on any of our products because it hasn't been required at this point, it is a really good tool to actually use to develop products, and another add-on which can assist with that, as Liam was saying, the storytelling, or in my model, it's very much the same. The storytelling is extremely important, but I call that the appreciation at the end, and the appreciation comes from the ability to have that story. And all of these tools and information about the product and how it's produced and where it's going to go and what can be done with it is extremely important. And that's another thing that I want to just bring up about the Reynard wood product. It's very important where George sort of articulated where that material does not have any plastic in it. When I see people incorporating plastic into concrete, I'm just like, oh man, what are you doing? Because it then turns two recyclable products into one non-recyclable product, which is effectively exacerbating the current issue that we've got here around microplastics. So you put polyethylene, PVC, crumb rubber into bitumen. I mean, wow, great, you're solving this problem. But in actual fact, it's bullshit, because you're just creating more microplastics and adding to the whole problem. So people who really understand the system that we're trying to push will understand that there's a lot of greenwashing and a lot of rubbish out there in the world today. And if I go back to we can, if we talk about the LCAs and this other process that we went through, which was an audit by Ernst and Young all around our compliance to be part of the PVC stewardship program. And we went through all of this documentation, provided absolutely every bit of information that we could muster and get together and produce, modern slavery agreements and lifetime assessments and all this sort of stuff. In the end, when they looked at all of our documentation, I said, okay, now do you want to come through and have a look at our factory? See how it's really done. They said, oh, no, we don't need to do that. We just need to see the paperwork. And I'm like, what? This is absolutely absurd. I could have just created all that paperwork, just, chat GPT, pump this out for me. And you can. It's not hard. So this is where we need to get a lot stricter in the auditing process, where it's not about your shiny, beautiful paperwork. It's actually out there. Go and have a look. Are you actually doing it? Are you doing what you're saying you're doing? So I don't know if that really answers the question. Was Dylan around the LCA, but I went off onto a tangent. That's it.
Well, there was actually a follow-up question as well about the life cycle of the products that you were supplying to the customers. Is there a method for, at the end of that usable period of those materials, can you take them back and reuse them?
Absolutely. Absolutely. And we actually provide a take back document with all of our products, and that's extremely important, especially for one of the products that we manufacture called EcoDuct, which is the recycled low-rise ventilation ducting for multi-story buildings. We need to provide a take back document and have evidence that at the end of the product's life cycle, we can take that back and turn it back into another product. So this also extends to the technology that we have developed in the way that we process our materials. So all of the additives that go into any of the products that we make, or any of the materials that we make for other companies, all of the polymers, all of the additives, all of the composites are compatible with each other so that they can be recycled again through the exact same process, where we don't need to go through a strenuous separation system or process in order to create a material that can be chemically and mechanically compatible and homogenized back into a usable feedstock. So extremely important, extremely important.
And George and Liam, did you have any thoughts that you'd like to add on the fact that when we're talking about circular economy, it's not just here's a thing, we reuse, recycle, etc., but then when that new product gets to the end of that usability, really focusing on the long term, not just that immediate, look, we fixed it.
Yeah, I think from my point of view and what I've seen as well from other people's efforts is, when you mix those two different maybe recycled products into making a new product, and then it's not recyclable is a key problem. And I think an example I've seen also is the plastic bottle caps. At the moment, we have two different types of plastics in there that can't be recycled, that needs a solution. So there's definitely a few, and with our product as well, we are actually pushing and making this thinner and longer to replace the plastic wood decking that you see. That's just like a massive fad at the moment. Everyone thinks it's great, and they're replacing the timbers with it. But yeah, you've got the microplastics as you cut it, and shavings and so forth going into the environment. So that's definitely a target market. We've already started a couple of years ago and testing back at factory. But plastic in the wood or these sort of materials does help it from a aesthetic look. So we're working to get there without having to use that plastic, like just what Jack was saying.
And you're
Yeah,
right.
yeah, I
Right,
agree.
Liam, go.
Yeah. Oh no, I 100% agree too. And I think everyone in this community, this forum, realizes that you don't really want to make the situation worse. And I touched on that a little bit before, and that most of the time you're adding materials when you're coming up with these solutions. So you need to be really conscious about the impact of what you're adding in.
And Jack, you were going to say something?
Oh, I was just validating George's comment there around the wood. But the big problem is with WPC is it's a wood plastic composite generally. So the way that they get timber to bond to polyethylene and some PVCs and these wild composites is quite complex. And then at the end, when that goes to be recycled, it's not a very straightforward process, if at all. So there are many, many products available today, which are WPC, and a lot of the rubbish comes out of China, which comes into this country, and it's just a way of China just pumping their scrap out into this terrible product, which they're just trying to sell it to, the lowest common denominator, which unfortunately ends up sometimes us. But there are some good companies in Australia that's doing some good things, like Mod Wood. They're making some pretty interesting composites. But what we've actually done, I'll just plug one of our products while I'm here. We applied this design process to a very, very interesting system, and that's called OneDeck, ONEDECK, which is not a WPC. It's a highly modified 90% recycled PVC ASA composite. So once again, two materials which are chemically and mechanically compatible. And we're using the technology we developed with CSIRO to analyze some really wide spec PVC. And then we're leveraging AI to then dose the material with certain additives to bring the polymer up to a standard. So I know AI isn't the flavor of the month at the moment, and everyone's saying AI. Yeah, right. But what are you actually doing with it? So we've applied AI in a very interesting way into our material dosing system. So after we analyze the polymer and get it to where we need it to be, in a broad sense, rather than chemically adding new material into that polymer to bring it up to a certain standard, we will have maybe 5 different silos of wide spec recyclate, and each of those silos has a specific grade of material that we work out through our system. And then to get a polymer to perform for a specific product such as decking, you might need high rigidity, you need good impact strength, you need a reasonable amount of ductility and UV stability. So what we do, rather than chemically modifying one of those materials, is we'll use AI. So we're starting to build a database, and we're doing some work with CSIRO and also with A²I² out at Deakin, where we're actually taking from 5 different materials certain ratios to get one master batch of material that performs to the standards that we've set out for it. And without AI, you would either have a library of 100,000 different variations on a spreadsheet, or you would try trial and error machine learning, which is sort of AI. But then the great thing with AI is where every time we run a trial, every time we run a sample, every time we analyze something, this is adding to that database, which we can then leverage to get from this material here to this material here in the shortest, most efficient way. So AI is just going to transform recycling. We're also using it for sorting material rather than using spectroscopy and chemical analysis. We're actually using the visual aspects of what a polymer or a recycled chunk of material looks like.
And if anyone wants to learn more about the environmental impacts of AI, both good and bad, that was actually the topic of last month's webinar. So if you go to the Boomerang Labs Learning Library on our website, all of the past recordings of webinars are there. And this one is going to be there shortly as well. It doesn't look like we have any more questions, so I think we're going to wrap up a couple minutes early.